All right, the last thing with force is if you have it at an angle. So something at an angle like this, 30 degrees. Let's say that we put an object on here that's got a mass of 3 kilograms, and we have it at 30 degrees. And what we want to know is if I tell you it is sliding, I'm going to go ahead and tell you it's sliding. It is sliding, and its coefficient of friction is 0.3. I want to know how fast it's accelerating down the hill. Okay? So the first thing you need to do is to draw a free body diagram on this object. When it's at an angle, I always draw the forces that would be acting on this object on here and then translate it to another picture. So we would have the normal force. The normal force is always perpendicular to the slope. You would have the force of gravity, which is always straight down. And you would have the force of friction that would be fighting the movement. It would be pointed back up the hill. Okay? So now I'm going to take that information, I'm going to shift it over here. Remember that we did this, like whenever we did stuff at an angle, we had to kind of like rotate it. So this would end up looking like this. Normal force, friction, force of gravity. And the angle here is the same as this angle. Okay, so if this is 30 degrees, that is 30 degrees. When you got this, the force of gravity in the x would be the opposite. Right? Force of gravity in the x is the opposite side of that angle. If you have an opposite, what do you do to find it? What do you use, sine or cosine? Sine. So the force of gravity in the x will be force of gravity sine theta, and the force of gravity in the y would be force of gravity cosine theta. So when you're doing this, it's the opposite of our the normal way we do it. Because normally it's fx is f cosine theta, but whenever it's like this, it's the opposite. Okay, so now I'm going to redraw it again. We have force of gravity in the y, normal force, friction, force of gravity in the x. All right, what would be the force of gravity on this object? 3 kilogram object. Force of gravity would be? 30 newtons. Okay, if the force of gravity is 30 newtons, then the frictional force, well, first of all, what would the normal force be if the force of gravity is 30 newtons? Would we automatically know that the normal force is 30 newtons?
Yes.
No.
JK.
Why not? Because all of the gravity is not directed in the y direction in this case, right? So we have to break it up. So what is 30 cosine 30? Somebody type it in for me.
A number.
30 cosine 30?
25.
25.6, is that right? Yeah? Yes? No? 25, just straight 25?
25.98.
Okay. So we'll call it 26. 26 newtons. Force of gravity in the x should be 30 sine 15, or sorry, sine 30, which would be 15 newtons. All right. Is this thing accelerating in this direction? No, right? It's not accelerating this way, it's accelerating that way. So what we know is that the force of gravity in the y is the normal force. When there's no acceleration in the y direction, the normal force and the force of gravity are equal. And then the last thing is we need to find this friction. So friction would be 26 times 0.3. The normal force times 0.3. So 26 times 0.3 is, if you could for me real quick, 5.2, 7.8?
7.
Okay.
Buckets.
7.8 newtons. All right, so now I want to know how fast this was accelerating down the hill. So I would do sum of the forces equals mass times acceleration. It would be 15 minus 7.8 equals 3 times A. And you could solve from there for A. All right? So that's when you got something at an angle. Anybody got any questions or concerns?
Cut.
All right.